In our final math lesson, we're going to revisit quantitative comparisons. For these questions on the official test, you have an average of 75 seconds per question. But for many of the 18 problems that follow today, you may be able to answer a lot more quickly if you remember some key rules. So, I'm not going to put up an official timer on these. I'll pause after presenting each question, long enough to give you time to hit the pause button, work on the problem on your own. You should be prepared to hit that pause button, have some scrap paper handy, as well as a timer. Be prepared to time yourself just to see how fast you actually are. So let's begin. On this question, Q is odd and Q is the exponent. Very much a rule-based question. The rule is when you have an odd exponent, it does not hide the sign. When you have an even exponent, it does hide the sign of the base. That's relevant when the base is negative, as it is here. And so you can quickly surmise that quantity A will be -1, not hiding the sign of the base, and quantity B will be +1, hiding that sign. B is the answer. This question tests the average rate fallacy. Mistaken thinking that the average rate for a trip is the simple average of the rate getting there and the rate coming back. That would give you 45 miles per hour. In reality, Maria spent more time driving slowly on the way there than she spent going fast on the way back. And that greater time spent going slow drags down the average speed. So that's the intuition. It's what you can rely on if you're familiar with this kind of problem. If not, you'd have to fall back on some math. So I highly recommend that if you set up a rate problem, you always just start by writing down the fundamental rate times time equals distance formula. And underneath that framework, then you can do your actual calculation. So time equals distance over rate is what we're going to be looking at. And always be clear on what you're solving for. The biggest mistake I see students make is writing down variables and numbers and no words indicating what they're actually solving for. In your mind, at the very least, you should be verbalizing to yourself, okay, now I'm calculating the time getting there. That's the distance out divided by the rate getting there. And time getting back, separate thing. The X distance, we don't know how far apart these two cities are, but just put a variable in for that. That way, when it comes time to do the next step, you know, okay, total time is just going to be the sum of those two things. And the average rate is the total distance over the total time. So when you actually do the math, 44.4 repeating is the average rate. So while the math is always something you can fall back on, it's obviously faster if you can recall on future problems that for weighted average rate for a trip, it's always going to be weighted towards the slower speed. And on this one, the exponents are a bit of a distraction. You might look at it this way. What is the remainder when 10 is divided by 2? Clearly, the answer is 0. And why is that? Because 10 is an even number. It's a multiple of 2. Well, the exponents are a distraction because they don't change anything about that. 10 times 10 times 10, all of those are even numbers, so they're going to give you an even result. Likewise, in quantity B, the base of 3 tells you no matter what power you raise that to, there's going to be a factor of 3 in the result. In other words, when a number that's divisible by 3, or one that would give a remainder of 0. So if you didn't recognize that just about the bases, you could think about it in a little bit more rigorous form, actually do the division in quantity B. Think about the units digits at the end of quantity A's big number. But here you go, both quantities are 0. Before you start plugging and testing numbers on any kind of QC question, see if you can clean it up a little bit first. It might save you some plugging time. And here, cleanup means look for what's common in both quantities. A is an obvious similarity in the numerator there. And no matter what A value we plugged in, it would affect both quantities in an equivalent way. So if we divide both quantities by A, cancel that out, we're not changing anything about the relative values of those quantities. And so this is really a question about, 1 over B versus 1 over B squared. At that point, you can plug in for B. 1 is an easy one to try. It makes them equal. And at that point, to try to prove D, plugging in any other number that would get a non-equal result would do it. And +2, -2, fractions, negative fractions, all good things to try here. D is the answer. Another driving question, another rate, time, distance problem. So write down that relationship. And if you just remember rate times time equals distance, you can solve that for any variable you're looking for. And here, time is what both quantities concern. So we've written our foundational formula in terms of time. And then it's just a matter of plugging in. So time equals the distance divided by the rate, both of which are given. Don't be weirded out by the variables. What you end up seeing is that m over 30 hours is the time in both cases. A more intuitive approach might be to notice that 5m miles is 2.5 times the 2m miles. Likewise, 150 miles per hour is 2.5 times 60 miles per hour. So if you're covering 2.5 times the distance at 2.5 times the speed, you'd still get there in the same amount of time. In an isosceles triangle, you have, by definition, exactly two sides that are equal, and the two angles opposite those equal sides are equal to each other. And here we're not given any side lengths, we're just given one angle measure. And just as a quick review, when angles are called out like this, A, B, C, it means that you can draw a picture that looks like this. Here, just some generic triangles are drawn. And notice that A, B, C as your angle call out means that the point of the angle is at B, always at that middle letter. And so here we've placed the 20 in there. And it's been drawn several times just to get, and this is a good practice on paper, get yourself thinking, how else could it look? Obviously it's not to scale, but it gives us a place to put the various angles. So it could be that angles A and B are the two that are equal, or it could be that B and C are the two that are equal. Or even A and C could be the equal ones and 20 could be the oddball. And all of those are going to lead to different values for quantity A. The way to read that is the angle that points at C minus the angle whose point is at A. So 3 different numbers. This answer is D because one of them is greater than 100. And 2 are less than 100. So the relationship could go either way here. Now, it's worth noting that if quantity B had been 180 or even 150, it would have been greater than all of these values, and the answer could have been B. So just because we have multiple numbers possible from quantity A doesn't automatically mean that the answer is D, but it does in this case. This one is testing exponent rules. 125 is a power of 3. That's the recognition skill you need to have. And remember how to use those exponent rules. Replace 125 with 5 to the 3rd. Raising that to the 25th power means you multiply the exponents. And now things are in the common base. You can just compare the exponents. 80 is bigger than 75. B is the answer. If ABCD is a square, we know all 4 sides are the same, and that makes quantity A, an easy one to start with. The square of the length of side CD, it's basically the square of the side of the square, which is the definition of the area of a square. Next, we turn our attention to triangle AOD, there within the square. First of all, notice that AOD shares a side with the square. They share side AD. And one key word to notice is the word twice in that quantity. Double the area of the triangle. So you can actually approach this in a visual way. If we carve up that triangle just by dropping a vertical line there, you can see that they're equivalent triangles. There's two triangles within our triangle AOD. And then there's sort of mirror images of those outside, comprising the rest of the square. And so, if we double the area, we're really doubling the number of triangles we have there. Clearly, those make up the square. If that's a little too visual and too reliant on the picture for you, you can fall back on formulas. So twice the area of a triangle is 2 times 1/2 base times height. And the 2 and the 1/2 will cancel, leaving base times height. Notice here the base of the triangle is a side of the square, as is the height of the triangle. So side times side again, area of the square. This question tests a rule that to me is a little bit similar to the rule about average rate for a trip. You don't get to just average the rates for a trip. Likewise here, when there's a markup and a markdown, or 2 markups in series, whatever it is, 2% changes in a row, you can't simply add the percent. So here, discount is minus 21, marking up a 21% surcharge, that's plus 21. That doesn't mean that the price has not changed. Why not? Well, because the 21% were taken on different amounts. The first discount was taken on the greater original price, so the discount was 21% of a big number, whereas the surcharge was 21% of the smaller price. So the surcharge was smaller. It got marked back up by a smaller amount. Doing the actual math, what you should do is times 0.79 to indicate 21% discount, and then 1.21 to indicate the 21% markup. In your calculator, that's 0.9559, just shy of the original price. And since we can, I don't want to say assume, it is implied that the price is a positive number. You can rely on that on the GRE, so no tricks there. This one tests exponent rules again. And before you start multiplying things out and manipulating within the quantities, look for similarities between the quantities. 4 is 2 squared, 25 is 5 squared. There's your similarity. And if you actually replace the 4 and the 25 by their powers of prime numbers, as shown, those terms in the 2 quantities are equal and can therefore be ignored. They're affecting both quantities equally, so we don't care about them. So really this question boils down to 7 to the third versus 11 squared. Numbers that you may know off the top of your head, or quickly plug into the calculator. This one tests exponent rules again, and most specifically the rule about division. When you divide, you subtract the exponents. So be very careful with the signs here. That's a negative exponent in the denominator, so it's 4 minus 3, which becomes 4 plus 3. So this is a comparison between m to the 7th and m. Be careful if you dropped that sign or mistakenly subtracted 3 from 4, you would have maybe concluded that the answer was C. This is not an m equal to m situation. We have to actually see what's going on. So m to the 7th is going to equal m if m is 1. But as soon as m grows, the balance shifts. A larger number taken to the 7th power is going to be larger than the original number. So here, plugging that in, it's 128 versus 2. So we can come up with all of the different scenarios. The answer is clearly D. On a number line question with no labels of what the numbers are, really all you can rely on from the picture is that A is to the left of B, B is to the left of C, and so on. You can rely on the order. And that does tell you that F is greater than A, because the number line always does run from left to right. Here, this is more of a segment. We don't really care about positives and negatives. Those lines above AE and BF tell you, look for the length of those segments. So even if they had called them out backwards, which I don't think they would do, even if it were the length of DC, that's still a positive length. So since it's about length, let's mark what we're looking for. So yellow line and green line, just to kind of keep it straight on the screen here. And if you picked C, it's possible that you said, well, each of those lines are 4 segments long, 4 increments long. The problem with that is they're not the same 4 increments. The increments from B to C, C to D, D to E are common to both, but the tail ends there, we don't know anything about how long AB is versus how long EF is. Don't assume even spacing, even if it looks like it's even spacing. The GRE would have to tell you in words or with some number labels that that's in fact the case. Slightly different question about the same figure. And on this one, we've got 2 line segments added together in quantity B, that's the green and the purple, and then quantity A is just one longer line segment. And here, notice all the overlap. The yellow line is equivalent to part of the green line plus the purple line. There's this overlap section, and we can surmise that quantity B is greater by that length. And since all lengths have to be positive, that means B is greater. So here we still don't know by how much. We aren't assuming anything about the spacing, but we can say for sure that B is greater. We have consecutive even integers, such that A is the smallest and D is the greatest of them. So go ahead and write just some test cases. You can refer back to these as you look at those differences in the quantities, the D minus C, B minus A. You'll find that those are consistent no matter which list you look at. And the math is pretty simple once you've identified what those numbers are. Another way to do this one that I think takes a little bit more time is to put all the variables in terms of A. B is 2 greater, C is 4 greater, D is 6 greater, and then just plug them in. You'd end up with those same numbers. You just would have at least a line of algebra before you get to those numbers. So B is the answer. In this one, you could start plugging in n values. And if your time was over 30 seconds and certainly over a minute, it's likely that you did plug some n values in. And that's a large range of n values to be testing. You also can't prove D for reasons we'll see. A better way to go is to try to clean up those quantities first. So if you add n to both of them, it actually cancels out. And what we're really comparing is 1,000 and -1. Well, that's straightforward. A is the answer. So it turns out that in this question, the value of n is irrelevant. So if your first move was to start dropping numbers in, you were suckered into wasting time doing that. Very tricky thing going on here. I think it's kind of sneaky that quantity B was not given in the same order or format as quantity A. I think it would have been easier to see what was happening here if quantity B had been written as -1 minus n, with number coming before the variable as it is in quantity A. Another one, you'd want to clean up the quantities before dropping in A values. And certainly you'd have a hard time figuring out what to do, even with a number subbed in for A, if you didn't know what to make of the -4 exponent in quantity B. This one really does test your rule knowledge. And the rule is that a negative exponent means inverse. So quantity B is really 1 over A to the 4th, which can be written as A to the 4th. Another way to see that is that 1 in the numerator could be written as A to the 0. So A to the 0 over A to the -4. You subtract the exponents. 0 minus -4 gives you a +4 exponent. And of course in quantity A, you're multiplying, so you add the exponents. 3 plus 1 is 4, and we're looking at the same thing. No need to plug. No matter what A is, those are equal. Whenever you see an inequality where 0 is on one side of that inequality, it's about sign. So don't worry about values, worry about sign. We can start with the first one, noting that the exponent on A is even. So A squared must be positive. And positive times what gives you a positive number? Well, B must be positive too. All right, so if B is positive, let's take a look at the second inequality. If B is positive, how will that product be negative? Well, you have to have something negative in there. A to the 3rd must be negative, which means A itself must be negative. And so here we're truly comparing. We don't care the values of A and B, but we do know that B is positive and A is negative. And this one is our last one in the set. As a quick review of absolute value, when you take the absolute value of a number, it becomes positive. So absolute value of 4 is just 4. So the absolute value bars do basically nothing when the inside number is positive. And absolute value of -4 is +4. So it changes the sign when what's inside is negative. So glancing down at quantity B, we're going to need to know what the sign of B minus A is in order to be able to bust that out of absolute value bars. We need to know what to do. So I'll put a little key in the upper corner. This is the rule about absolute values. When x is positive, the absolute value equals x. When x is negative, it equals negative x. So for example, absolute value of -4, negative of -4 makes it positive. Okay, so to find out the sign of B minus A, we have to figure out something about B and A. And no numbers are actually given here. We're told that M and N are prime. M is greater than N. A is a prime number too, the least prime number greater than M. B, same kind of deal in relation to N. B's a prime. So all these numbers are prime. I would start with a number line with primes on it and see what that means. So here are the first few primes written out. And N, B, M, and A placed there. So notice that M is greater than N. They're both equal to primes. And here it's easier to make sense of the whole least prime number greater than M. Well, A has to be a prime. It's greater than M, but it's the least one of those that's possible. So it's the next one up, would be another way of saying that. Likewise, B is the next prime up from N. All right, so we're actually getting somewhere here, because now we can look at A and B in relationship to each other. A is a greater prime number than B is. So if we plugged these in, quantity A would be equal to 10, 13 minus 3, and quantity B would also be equal to 10, because it would be the absolute value of -10, which is 10. Okay, but that doesn't prove anything. You can only prove D by plugging numbers. Let's investigate the number line further. M and A don't have to be there. They could even be closer to N and B. So notice that we move these, and M is still a prime number greater than N. B and A are still the least prime numbers greater, the next primes up from those numbers. And this is actually the minimum or the closest that m can be to n, because m and n can't be equal to each other. B can't be greater than m. B and m can be equal. But what's always true is that A has to be greater than B. So since this is kind of the closest they can get, this is the extreme case. And we can surmise that B is definitely less than A. And if that's true, well, we can just apply that formula. So if B minus A is always negative, that absolute value bar always changes the sign. So pop a negative sign in front of B minus A. It's out of the absolute value bars, and it becomes A minus B. We've proven that no matter what, C is the answer. So tough question there at the end. I think that one is the one that would probably take closest to 75 seconds among this whole set. So as you continue doing QC problems and other GRE problems, be on the lookout for those little shortcuts and rules that speed things along. Certainly if you do a problem inefficiently the first time, don't beat yourself up about it, but do note on a flashcard what it was that you didn't notice the first time. Really seeing that rule and writing it down and revisiting it will help you recognize it again in the future, and you'll be much faster the second time you see any given rule. Good luck!